So this video is going to be about balancing chemical equations. And just as a reminder, I think you guys should have the link to the slideshow. So if you want to go back on your own, make sure you're watching in slideshow mode so that you don't accidentally spoil any of the answers for yourself in the practice problems. Okay, so to get started, quick overview, what are chemical equations? So chemical equations tell you what reactants create what products. So, as a reminder, your reactants are the substances that you start with that react with one another to create your end product, your end substance, also known as your products. So, for example, in this equation here, you have these two reactants react with one another to form one product. Some important things to keep in mind. The subscripts of elements tell you how many atoms of that specific element are present. So for example, this nitrogen over here, this subscript of 3 tells me I have 3 atoms of nitrogen. Um, and then over here, this subscript of 3 tells me I have 3 atoms of hydrogen, not 3 atoms of hydrogen, 3 atoms of nitrogen, just 3 atoms of hydrogen, since it's only under hydrogen. However, coefficients do apply to the whole molecule. So, for example, over here, I have 2 hydrogens and then I have I have 2 nitrogens and then I have 6 hydrogens. So it applies to the entire molecule and it tells you how many of this entire thing there are. Okay. So why do we balance chemical equations? To follow the law of conservation of mass. So
Matter.
energy cannot be created or destroyed, but it can be rearranged, which is what happens in chemical equations, in chemical reactions. So to account for this rearrangement of matter, we can change the coefficients of I should say molecules, of the molecules or elements, whichever one it is. But we cannot change the subscript of the elements. And by doing this, you are keeping the amount of matter constant from reactants to products, which is important. Okay, so some things to consider when balancing chemical equations. Number one, you always want to leave your answer in the simplest ratio of coefficients. So basically what that means is if you have a common denominator between all of the coefficients across all of the reactants and products, you want to divide it by that common denominator to get simpler form. So for example, here, you have coefficient of 4 and 2 on the reactant side and 4 on the product side. 4, 2, and 4 all have the common denominator of 2. So to have it in the simplest form, you would want to divide each of these numbers by 2. So 4 divided by 2, 2, 2 divided by 2, 1, 4 divided by 2, 2. So this would be a correct answer, and this would be incorrect. Right. And then number 2, if there is a polyatomic ion that remains intact from the reactant side to the product side, you want to keep it together as one when you're thinking about balancing it. And in this unit especially, it's very important to remember your polyatomic ions by formula and name. Okay, number 3. If you're balancing an equation with carbon, hydrogen, and oxygen, or any combination of the three, or any two out of the three, then you want to balance them in that order: carbon, hydrogen, oxygen. Okay, number 4. If there's an odd subscript, this is my personal favorite hack. If there's an odd subscript on either side of the equation, then I like to start by doubling it. It doesn't necessarily always mean that that's what the coefficient will end up being, but it makes it easier to work with. Okay, so practice problem. So a student was given this equation right here to balance, and this is what they answered with. Are they correct? I'm gonna let you guys pause the video, give you a couple seconds, think about it on your own. Yeah. 3, 2, 1. No, they are not, because the law of conservation of mass was not followed. But how do we know that? You can break it down into a chart, which is what we've been learning in class to do for these problems. And when you do that, you can see that the number of atoms for hydrogen specifically does not stay the same from the reactants to the products. Because here you can see in the reactants here, you have 2 hydrogen, but then on the product side, you have 4 hydrogen. And since matter cannot be created, that would not be possible. So what they would need to do instead is balance both the hydrogen and the oxygen. So they had the right idea, which is they changed the coefficient of the product. They put a 2 here to match the number of oxygen atoms on both sides. But they didn't do the same for hydrogen. So instead, they can alter the coefficients on both the reactant and the product side to create a fully balanced equation. So this one here, you have four hydrogen, two oxygen. So it's balanced. Okay, so here's some practice problems. Pause the video, do them yourself. Um, I personally, I've just been doing them for so long. I kind of think through it in my mind, but I definitely do think if you're maybe still having a little bit of trouble with these and they don't really like they take you a little bit longer or they might feel a little bit harder, then doing a chart for it is completely fine. And I think really helpful for especially the harder ones, like number 4 down here. Okay, so answers in 5, 4, 3, 2, 1. Okay, so here are the answers for this, but wait, there is something wrong. Number 4 is incorrect. Why? Give you a second, figure it out. 3, 2, 1. Because it's not simplified. The coefficients are not fully reduced to the simplest terms. So 12, 2, 6, and 4, they all have a common denominator of 2. So I should divide them all by 2 to put it in the simplest form, and this would be my correct and final answer. Okay, so to walk through these problems, here's how I would think of it. As a reminder, I think these problems are very much trial and error, but they're also something that you can definitely get better at just by doing more and more of. I know for me personally last year, it took a while to kind of like get the hang of it, but then once you do, it just gets easier and easier and comes more naturally. So I'm just going to do these problems by explaining my thought process. Um, but of course, there's nothing wrong with doing a chart and it's absolutely helpful. Okay, so for number 1, looking at the subscripts, I see that oxygen here has an odd subscript. And if I think back to my tips, I remember that if I have an odd subscript of something, it's not a bad idea to just start by doubling it. So that's what I would do personally. And again, like a reminder, a lot of this is guess and check. Like you could get almost all the way done by balancing an equation and then get to the last substance and figure out that it's wrong and then just have to start again. But that's okay. That's just the process. Okay, so if I put that 2 there, then that gives me 6 oxygen on the product side, which I would need to balance on the reactant side. So looking at the reactant side, I have oxygen with a subscript of 2, meaning there's 2 atoms here, and I need 6 total atoms to balance it. So to get from 2 to 6, I multiply by 3, so I'm going to add a coefficient of 3 here. Okay, now to balance my aluminum, aluminum here has a subscript of 2 and a coefficient of 2. So these 2 aluminum atoms multiplied by 2, 2 times 2 is 4. I go over here. The aluminum doesn't have a subscript, so 1. So to get from 1 to 4, I would put, I need to multiply by 4, so I put a coefficient of 4 here. Okay, and then I want to check and make sure that everything's fully balanced. So 4 aluminum on the reactant side, yes. 4 on the product side, yeah. Oxygen, 6 oxygen atoms on the reactant side, and then 3 times 2, 6 on the product side. And then I also want to make sure that it's fully simplified. So do 4, 3, and 2 have any sort of common denominator? No, they don't. So it's fully simplified. Okay, so moving on to number 2. So this one can look a little bit trickier because you have oxygen in 2 different places now on the product side, but there is a tip for this. It's to solve in the order when you have carbon, hydrogen, and oxygen. Solve for them or balance them in that order. So I'm going to start with carbon. So looking here, I have a coefficient, or sorry, a subscript of 2, subscript of 1. So I have 2 atoms to start with here, 1 atom to start with here. Okay, so I'm just gonna try, could be wrong, but I'm just gonna try to double this to start with, because that balances my carbon, 2 here, and see if that takes me anywhere. Okay, so then I would just have a 1 here, or I guess you don't have to write anything, but 1. Okay, so then from there, I would know how many hydrogen I have on the reactant side, because it only comes up once here, right here. So hydrogen has a subscript of 6, with a coefficient of 1. So there's 6 hydrogen on the reactant side. Okay, looking over to the product side, um, hydrogen only comes up once, so I'm only going to be looking right here. It has a subscript of 2, and I need to get from 2 atoms of hydrogen to 6 atoms. So I'm going to multiply by 3. So I put a coefficient of 3 here. And then all I have left is to balance this right here, my oxygen. Okay, so looking at the product side, we have 3 atoms in this molecule right here. And then we have 2 times 2, 4 atoms of oxygen in this one here. So 3 plus 4, 7. Okay, I can double check. Do I have everything balanced? Carbon, I have 2 here. Do I have 2 over here? Yeah. Hydrogen, 6. I have 6 here. Yes, 2 times 3, 6. And then oxygen, 7 here. 2 times 2, 4. Plus 3 times 1, 3. So 4 plus 3, 7. Yes. And then final check, is there anything to simplify? 1, 7, 2, 3. No, they don't have a common coefficient, or sorry, common denominator. So no, I would leave it like that. Okay, so number 3. Uh, okay, number 3, I see that I have hydrogen and oxygen. So thinking back to that tip, I'm gonna do them in that order of hydrogen and oxygen. So to start off with hydrogen, I'm gonna look over here. I'm gonna start with this hydrogen instead of this one because it's a odd subscript. So I'm just gonna start by I usually tend to do and double it and see if that um, does me any good. Okay, so if I double it there, then that makes these 3 atoms of hydrogen now into 6. So then to balance that, I'm gonna put a 3 here. 2 times 3, 6. Hydrogen balanced. Okay, moving on. Now since I put that 2 there, that means that I would have 2 atoms of nitrogen on the reactant side. So to balance it, I already have 2 on the product side, so I can just put a 1 there. And then moving on, lastly, oxygen. Oxygen, no subscript, coefficient of 3. I have 3 atoms of oxygen on this side. And then looking over here, oh no, it has a subscript of 2, and there's no whole number that I can put to go as a coefficient to get from 2 to 3. So that means I gotta backtrack and figure out what I can change so that I can actually balance them all. Okay, so I'm gonna, okay, I would go back here to my first step because I do still want to get rid of this odd subscript here. So instead of multiplying it by 2, I'm gonna double it by another even number, but higher this time, and see where that takes me. So instead of 2, I'm not gonna do 3 because that's all. I'll do 4. Okay, we'll see what that gets me. So if I put a 4 there, 3 times 4, 12, 12 atoms of hydrogen here. Looking over here, subscript of 2, to get from 2 to 12, 6. Put 6 there. And then looking at nitrogen, 4 atoms here. Over here, a subscript of 2 to get from 2 to 4 multiplied by 2. So I put 2 there. And then lastly, oxygen. Um, I have 6 atoms here, and I have a subscript of 2, but now I can multiply something to get from 2 to 6, 3. Okay, so now to check to see 4 nitrogen here, 4 nitrogen here, 3 times 4, 12 hydrogen here, 2 times 6, 12 hydrogen here, 2 times 3, 6, 6 oxygen here, 6 oxygen here. Okay, so it is balanced. And then looking if I can simplify, 4, 3, 2, 6. No, they don't have a common denominator, so it's good. Okay, so for number 4, this looks a little bit trickier. I would probably recommend doing a table for this, just because it's a little bit more complex, but I'm just going to show you guys how I would think through it in my head. Okay, so I see here that I have some polyatomic ions. I have hydroxide here, I have phosphate here, but we can see that only phosphate remains from the reactants to the products, right? Phosphate's here and then it's here, but hydroxide, it's here on the reactant side, but then it's not here on the product side. So when I'm balancing, I'm not really gonna try to be keeping this hydroxide group together, um, or like keeping that in mind as I'm doing that, but I will be for the phosphate. Okay. Anyways, thinking back to my tips, that was one of them. Another one is if you have carbon, hydrogen, oxygen in the same equation together, you do them in that order of carbon, hydrogen, oxygen. So I have hydrogen and oxygen, so I'm going to do that in that order, starting with hydrogen. Okay, so hydrogen comes up a few times here. I'm going to start with this one because it has an odd subscript. So I always like to start by doubling anything with an odd subscript just to kind of help myself out a little bit. Um, okay, so I see that if I do that, if I double it and I put a coefficient of 2 in front of it, now I have two of these phosphates. Okay, so if I look at this side, I also have two of these phosphates, right? Because as a reminder, just because this little number is down here as subscript, it doesn't mean it only applies to the O, right? It has parentheses, so this little 2 would apply to the whole polyatomic ion here, all of phosphate. So I have two phosphates here, so that's also already balanced. So I'm just gonna go with that and put a 1 there and see if that gets me anything. Okay, so if I go with that and I put a 1 here, then that means that I have 3 calcium atoms on the product side, which means I have to balance it on the reactant side. So looking over here, to get from this 1 atom here to 3, I multiply by 3, so I'm going to put a coefficient of 3. Okay, so I'm making progress. So now this is really the test of whether or not I have to redo it or if it's right. Okay, so looking at the hydrogen, now I have 6 here, right? I have 1 in this hydroxide group times 2, 2, and then this whole thing, all this right here, has a coefficient of 3. Sorry, of 3. Column 3. So 2 times 3, 6. So I have 6 hydrogen atoms here, 6 hydrogen atoms here, 6 plus 6, 12. You get from 2 to 12, I need 6. So I'm going to put a 6 there. Okay, now is when I would check it, but I'm just going to save us the time. It is balanced, everything of the numbers of atoms are the same from reactants to products. But I am going to check, can I divide by anything? Coefficient 6, 1, 3, 2. No. Okay, so boom, done. Okay, this one's definitely harder than a lot of the other ones we've seen before, and probably most of the ones that will be on your test, but it's still good practice. I'll post a video about my explanation of it tomorrow. Okay, answers in 3, 2, 1. Okay, that's all for this video. Bye.